Okay, good. Yeah. So in the previous class, we have seen just descriptions of all the form, like various statistical terms, right? Like we have seen median, mode, and everything. Mean, median, mode, and after that, we have seen skewness and all to check the asymmetry of the data points and all. Yeah, and we have seen it in Excel sheets also, right? Yeah. So today we'll look into the formulas. Mathematical formulas are available. We already know that they are mathematically available, and we have seen like the functions. We have used some functions in Excel, and we have executed our respective formulas. Right? We'll just see the formula. Understanding the formula is also very important sometimes. But yeah, so most probably we'll use Python only to get the formula values and all, like by getting the name and all. So the entire formula, whatever the math is there beneath it, the Python takes care of it, and it gives us the respective output. Okay, as you can clearly see, I have given the mean here. The mean is mostly widely spread measure of central tendency. Okay, so see, whenever the central tendency is there, think like this. See, the mean is like surrounded with all the data points. You can assume like that, right? Because if you take the average, you'll get the center point of the entire data set actually. That means, so from the center, what are the things you can do and all, that mean will explain us a lot. Okay, yeah. So note, it is easily affected by outliers. Okay, last time we have seen outliers, do you remember? Like for the checking the skewness and all, I've said like we'll be having outliers. So the outliers, the pattern, the pattern will change if any outlier is present. Like if a particular data point is observed, like it's not from a group, it is like separately having its own pattern kind of. Separately, it is there. I mean, if a separate data point is there, like 1, 2, 3, 4, 5, 6 belongs to the same group, but 1000 is the separate data point, kind of. So that makes the outlier there. See, mean is easily affected by outliers. See, that means if any outlier is present, automatically the mean will change, right? The mean will have a maximum value. So the mean is supposed to be in between all the data points. Then only we'll get the maximum pattern definition. Okay, remember this statement, that the mean should be in between the data points. Then only we'll get the maximum pattern definition. Like the patterns, whatever are there, we can define the patterns properly and we can train the machines. Okay, and the formula to calculate mean is C, summation I equal to 1 to capital N, xi by capital N. Okay, that means like for calculating the population mean, we use capital N. For calculating the small sample mean, we use small n. Remember that, small n. Okay, summation I equal to 1 to N, xi by N. That means xi is all the data points, the summation of all the data points to the total number of data points, right? So in Excel, the mean is calculated by using average. This thing we already know. In the same way, the median is the midpoint of the ordered data set. It is not as popular as the mean, but is often used in academia and data science. Okay, so it's not that popular, but yeah, median, sometimes we use the median in data science. That's what, for calculating mathematical operations or in order to manipulate the data or something, we come across these kind of formulas. Okay, not only this median and all, sometimes we do exponential, logarithmic value, sometimes we do sine, trigonometrical functions as well. Sometimes, whenever there is necessary, we use the trigonometric functions as well. Sine theta, cos theta, tan theta, sometimes we use those as well. And mode you already know. So it's very simple. See, skewness, I was talking about this yesterday. So if the skewness is towards the right, the skewness, if you see the skewness is in a positive way, that means the outliers are always towards the right. Okay, so check the graph here, So the mean is present here, the median is present here, and yeah, so median and mode is present here, for example, for these entire data points, right? So for these entire, if it is rightly skewed, rightly in the sense, if the curve is not symmetry, and if it is showing right side more compared to the left, that becomes a right skewness. Okay, if the curve is not symmetrical, again, if the left portion is very big compared to the right portion, that is the left skewness. Okay, that means you'll identify that there are outliers present in the data. Yesterday, I have, the last class, I have shown you that if the skewness comes in negative way, that means outliers are aligned towards the left. Okay, if the outliers are present towards the right, the curve is aligned towards the right. That means outliers are present towards the right completely. And this is the formula for skewness actually. Since we have already used a skew function in Excel, just remember this formula. So we'll not use this formula. If you want to use this formula, you can calculate this in Python as well. Like you can write a customized function for yourself with the name skew, and you can send the data points into that function in the form of a list or something, and then you can use the formula and you can do it. Yeah. So the formula for skewness is 1 by small n, summation I equal to 1 to n. Remember, whenever you are using small n, small n and capital N vary. See, capital N, we use it for population. In the first class of statistics, I told you, the population, the numbers are represented with capital N. For sample, it is represented with small n. Okay. The formula to calculate skewness is 1 by small n, summation I equal to 1 to n. Xi is the data point and x bar, I mean, that is called as mean, right? So the mean of all the data points, you are like cubing it, and then you are multiplying it 1 by n, and then divided by cube root of 1 by small n minus 1, summation of I equal to 1 to n, xi minus x bar whole square here. Okay, that's how you get the values of skewness, I mean the value of skewness. So if that is close to 0, that means all the data points are symmetrical in nature, and we can find good patterns in that. And yeah, we can find good patterns. So for checking the outliers and all, now we use this skewness. If you think that outliers are present in the data, we need to eliminate those outliers. So there are different ways to check outliers are present in the data or not. So one of the ways is skewness. Clear? Yeah, I hope that's clear. See, this variance and standard deviation. See, we all know about the formulas of standard deviation and variance, but how come the standard deviation and variance are used in a practical way? See, variance and standard deviation measure the dispersion of set of data points around its mean value. So the spread of data points around the mean value, is calculated by using variance and standard deviation. Remember, so how vastly the spread is there in the data points. So if the spread is like it's not in a diagonal way, for example, I said if the spread is not in a diagonal way, then we don't have patterns present in the data, right? If it is diagonal, I mean the spread is like in a diagonal way, then we have patterns present in the data. We have patterns present in the data. Yeah. So there are different formulas for population and sample variance and standard deviation, right? I mean, there are different formulas for population and for samples, right? Yeah. So we'll see. We'll look into the formulas actually. Okay. So okay, sample variance formula. For sample, this is the formula. So S square. We represent sample variance by using S square. Okay. S square equals to summation I equal to 1 to n xi. Same thing, xi minus x bar whole square to the by n minus 1. So we use this formula to calculate the sample variance. In the same way, we use this formula to calculate the population variance. See, x bar is the mean for samples, mu is the mean for the entire population. Remember, that same thing, the mean only, but it varies. Like if you're considering the population, you use a different symbol. If you're considering the sample, we use a different symbol. And the same way, we have square here. If you take out the square, and here we will have the square root of all the for the entire formula, right? Yeah, that becomes the standard deviation. Okay. Yeah, like we can use variance or standard deviation to define the dispersion, I mean the spread of the data points actually. See, the center point is the mean now. See, the point 1 and point 1, point 2, point 3, point 4, point 5, point 6, how vastly they're spread in the space, in the dimension space. See, and based upon that, we can decide whether the data points need to be cleaned or not. I mean, like data cleaning should be done or not. Like data cleaning, like if any values are missing, like, or if you want to eliminate the outliers. Likewise, we have few procedures, for cleaning the data and all. Okay, so that's how the variance and standard deviation are important, because with that only we understand how vastly, I mean how the spread is, how the dispersion of set of data points. Okay, it's a measure of dispersion of set of data points actually. Yeah, so that is, yeah, and the next terms are covariance and correlation. Okay, understand these formulas perfectly. See, covariance is a measure of the joint variability of two variables. Okay, yeah, so the joint variability of two variables, in the sense we have till now we have seen only x values. For example, what happens if there are x and y? So X has some data points and Y has some data points. Okay, and you need to understand the relationship between those two data points. So how we are going to do it? Okay, see, if you get a positive variance, okay, first these are the formulas for sample variance and population covariance. Okay, yeah, same thing. So Xi is the data point present in X value, and X bar is the mean for that entire sample, and Y values and Y mean to the n minus 1 divided by small n minus 1 for sample. For population, there's a different formula. I mean, just a little bit it varies, but it's almost the same. Okay, yeah. So a positive covariance means that the two variables move together. Okay, what do you mean by this? So if you have a positive covariance, that means the two variables move together. And suppose if the X value is increasing, Y value is also increasing. That means they're moving together. If the X value is 1 and the Y value is 1, I mean, for example, the initial point, and second point is 2, the X value is 2, and Y value is also 2. Third point, X value is 3, Y value is also 3. Likewise, the values increases accordingly. The positive covariance means the two variables move together. I mean, in an increasing order, they move together, or in a decreasing order as well. That's up. In decreasing order also, if they are moving together, that is called as positive variance. Okay, yeah. A covariance of 0 means that the two variables are independent. That means one variable is not dependent on other. There is no particular pattern in it. If the covariance is 0, at that time, what we need to do, right? A negative covariance means that the two variables move in opposite directions. That means if the X value is increasing, Y value will decrease. You understood, right? If the X value is increasing, the Y value will decrease. If the Y value is increasing, the X value will decrease. So that is called as negative covariance. So covariance can take on values from minus infinity to plus infinity. Like whatever the values you have, any minus infinity to plus infinity, it takes up all the values. Yeah. So this is a sample covariance formula, and this is the population covariance formula. And yeah, so in Excel, if you want to write like for calculating sample covariance, you use covariance.s, and for calculating population covariance, we use covariance.p. Okay. In the same way, correlation is also a measure of joint variability of two variables. But see, what is the difference? Unlike covariance, correlation could be thought of as a standardized measure. Standardized, I mean, that has standards to it. Everyone uses this, So it takes on values between -1 and 1. See, covariance, it takes the values, I mean, it can take the values from minus infinity to plus infinity also. But for the correlation, if you consider correlation, it takes the values from -1 to 1. Thus, it is easy for us to interpret the result, right? Covariance also does the same job. But if you take the values from minus infinity to plus infinity, it's very difficult for us to interpret the results, right? At that time, now we use correlation. We go for correlation. I mean, the covariance and correlation are same, but the major difference is covariance take the values from minus infinity to plus infinity, whereas this the range of the correlation, the values, between the -1 and 1. Okay, it's the same thing. A correlation of 1, like if it is a positive correlation, that means one variable is perfectly explained by the other. That means them both move in the same direction. Yeah, a correlation of 0 means that the variables are independent. Again, a correlation of -1, known as a perfect negative correlation, means that one variable explains the other one perfectly, but they move in opposite directions. Okay, sample correlation formula. See, for the sample correlation formula, Sxy by Xx XSy. So these are the I mean, what do we call? So these are the variance covariance formulas now. So you're combining the covariance formulas and you're using it inside that correlation, and likewise you are getting the output. And directly you can use the correlation by using this CORREL correl function in the Excel. Clear? Yeah, good. So today we'll do a small prediction. Like we'll learn how to predict by using the Excel sheets. I mean, by using the population and sample. Okay, we'll learn it. Okay, I'll open the Excel. Okay, so I'll randomly generate at least 100 of the data points. Okay, we'll randomly generate 100 data points. Okay, so how to generate 100 random data points inside the Excel? Okay, let us see. Rand and between. Yeah, we have the function rand between. Okay, we'll generate bottom and top. We'll use 0, comma 2000. Not 2000. We'll use a little less, 1000. Okay. So I'll randomly generate. I'll take 100 rows now. I'll take 100 rows. Yeah, there you go. So we have random data points of 100 rows. Okay. I always tell you, no, we in order to do predictions or something, no, we use good mathematical formulas to do the prediction part and all. What okay, before these machine learning algorithms or something, like before this machine learning or statisticians used to predict the outcomes, so by using simple formulas, people used to predict the outcomes actually. So how? So we can use our own calculations to predict the outcomes actually. Okay, I'll tell you how to predict something. Okay, so now what we'll do is we'll calculate the actual mean for this entire population. Getting my point, right? So we'll calculate the actual mean for this entire population first. Okay, so I'll use here actual mean. Okay, I'll consider this average of this, and then tell here. Yeah, yeah. So if I calculate the average, I got 512.16. Oh, are the values changing? No, the values are not changing. Yeah. So the actual mean, we have calculated the actual mean. So what happens now if I have samples present with me? What only samples I have and I need the actual mean of the entire population? Think that this value is unknown to us. We don't know the value, but we need to calculate the mean. We have only samples. People has given us only sample data actually. Okay. Let us consider 4 samples from these 100 data points. 4 samples. Okay. I'll take sample one. I'll take sample one, and what I will do is, oh, the mean value is changing. Okay, I'll copy these values because the formula, yeah, good. Now let us see. Okay, now we'll calculate the average for B column because the values are changing, right? So we need to make sure the value should be constant every time. Oh, again, these are also changing. Oh, okay. So I need to paste it. Text. Now we have the numbers, right? I need to paste it only with the numbers. Good. Now it will not change. Okay, I'll remove these 2 columns and I'll move delete. Yeah, good. Now I'll consider A1 to A100. Remember, the values are changing because of the formula. So that's why I've taken, I've copied that without the formula, the values, we need to have static values because while calculating the samples and all, if that change, that will not work because we need to have the actual values with what you're calculating. That only will help us. Okay, so I'll consider first 20. Let us take average again. Okay. I'll calculate the first 20 values. Good. So I got sample 1. Now I'm going to take sample 2 with the next 20 values. For the next thing, I got sample 3, 20, 20, 40, and we'll take average of, okay. So we'll consider from 41st to 60. Okay. Yeah, we're good. And now I'll take sample 4. So randomly I'll pick like from 7 to n number of samples. I don't know. Like we'll select randomly. Something like from 8 to 16, 9, 22. Okay, so now we got like 4 sample means here. We have 4 sample means, right? So now what I will do is I'll calculate the mean for all these, for all the 4 values. Okay. Okay. All samples. I'm just giving the heading as all samples. I will consider the average for all these four. See, now we have predicted that the sample, with the samples, the population mean might be 476, but the actual mean is 512, which is close, right? At least we are close to it, right? So by understanding this, what you need to understand is like we need to select perfect samples to predict the actual mean, right? To predict the actual mean, right? So 476 is not okay, a little bit close only still. So we have predicted the population mean by using the sample means now. Like 4 samples we have taken and we have predicted something out of it, right? So that's how this is one way. This is a simple approach which I'm showing you, like for understanding the predictions and all. So people use these kind of techniques previously and so long, and after that, mathematicians have developed so many great algorithms, which performs very well, and it gives us the better output. Clear? Yeah. So by using Excel, you can create there are so many statistical formulas present in Excel. You can play with the statistical formulas, right? Yeah, we can play with the statistical formulas now here. That's good. Okay. Okay. So now this. Okay. So the next topic, what we are going to enter is that is called as inferential statistics. Inferential statistics. Okay. So what do you mean by these inferential statistics? Let us see. Yeah. Yeah, these stats refer to the methods that rely on probability theory and distributions, and particular to predict population values based on sample data. So that's what we have done, right? So we have used samples of mean, and we have calculated we have predicted the population mean actually. But here, we use probability theory and distributions as well. Like now, after the mean and all, that's a mean is a simple thing. Now we are slowly moving into probability theory and distributions and all to, in particular, if we want to predict out population values based on sample data and all, we are moving further now. Okay, like we'll first start with distributions actually. So in stats, we use distributions, means there is probability distribution. Whenever you come across this distribution and all, you'll understand that it's a probability distribution. Okay, see, in statistics, when we talk about distributions, we usually mean probability distributions. Definition: a distribution is a function that shows the possible values for a variable and how often they occur. Yeah, that's the definition. And this is a definition in Wikipedia. Just look at it. That's it. And examples for popular distributions are normal distribution curve, student tree distribution, Poisson distribution, uniform distribution, and binomial distribution. Okay. Yeah. So these are the popular distributions actually. Okay. Yeah. So it's a common mistake. See, graphical representation. It's a common mistake to believe that the distribution is the graph. In fact, the distribution is the rule that determines how values are positioned in relation to each other. Okay, like how values are positioned, how if they are related with each other or not. How? So very often we use a graph to visualize the data. Since different distributions have particular graphical representation, statisticians like to plot them. There are different distributions or different graphs actually. Okay, like for example, for uniform distribution, this is the graph, and for binomial distribution, this is the graph. For normal distribution, this is the graph, and for students t distribution, this is the graph. Okay. 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 Before going further, hold on. Yeah. So in stats, if we distribute 3 types of distribution, these are very important. There's 3 distributions actually. So normal, binomial, and uniform. Okay. Let us see. Uniform distribution. Okay. Uniform distribution is something where the entire data points are distributed uniformly, equally. Okay. So that means probability for a die, all possible outcomes. Yeah. Can anyone tell me, like everyone has come across this probability in your math classes and all, right? So can anyone tell me what is the probability of getting a 1 for a die?
1/6.
1/6, right? That's
1 by
right.
6.
So the chances, the chances of getting 1 out of 6 values is 1/6. 1/6 chance, we have that. So each probability distribution is associated with a graph describing the likelihood of occurrence of every event. That means occurrence of 1 is 1/6. So that thing we are going to represent that in the graph. Okay, draw a graph, you'll find it, but remember, graph is only a visual representation. Okay, the graph is only a visual representation to understand the things. But yeah, so the main intention, the uniform distribution is like it distributes everything equally actually. Okay, so if you take a die, the probability of getting 2 is also 1 by 6. The probability of getting 3 value is also 1 by 6. That means the probability of getting 1, 2, 3, 4, 5, 6 are all same. That means they are uniformly divided, right? So that's how the graph looks like. So if you come across this kind of graph, then you need to assume that this is a uniform distribution. This is a uniform distribution. Clear?
Yes, sir.
Yeah. Next thing. We'll enter into this binomial distribution now. Okay. So binomial distribution is something, if the values gets increased more, like since one die is okay, one die we have done it. But what happens if you have 2 dice at a time? Like probability of getting, yeah. So the possibilities are this, right? If you have 2 dice, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Likewise, we have 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, and so on up to 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So these are all the possibilities, right? So my question is, what is the probability of getting sum of 1? Can anyone tell me? What is the probability of getting sum of 1?
1, 1, 2, 1, 3, 1, like that we'll get, sir. Up
Yeah.
to 6.
6 by 36.
Yeah. So that's right. So probability of getting 1, 1 is not available actually. Sum I am telling you. So 1 plus 1 is 2, right? There is no 1 here actually. So getting confused. Okay, if you consider 2, then you'll understand. Like 1, 1 is one possibility, right? 1 by 36 is a possibility there, right? Likewise, if you increase the sum now, so you'll get this kind of chart. The outcome 2, 3, 4, 5, 6, 7, 8, 9, and 12. All else are 0 actually. So remaining everything you can't do it. So this is the probability actually. So if you see the probability here from 2 to 12, the probability is increasing, and from here the probability is decreasing again. Can you check it? So this is a pattern actually. This is a pattern actually. It's till 7 it has increased, and after the 7 it started getting decreased actually. Okay, see, so this is the graph for it. So from 2 it goes straight like this here, and it comes down like this. Remember, this is just a graphical representation. I'm again telling you, because normal distributions, if you draw a line like this, it becomes a symmetrical distribution curve as well. So that means the data points are symmetrically divided actually. If you draw a curve like this, the entire curve is divided symmetrically. If you cut the curve in half, you'll get both equal halves. See, check this, equal halves. If you cut till at 0.17, you see these values are same and these values are also same, right? It's a symmetrical curve there for us. See, that's how a curve can be, the normal distribution, the normal distribution. So normal distribution is also known as Gaussian distribution or the famous bell curve. We call this as the bell curve actually, bell curve. Okay, it is one of the most common distributions due to the following reasons. Check this here. So it approximates a wide variety of random variables. Yeah, it gives us an approximation by looking at the line. No? So all the random variables will be connected to the data point, and we can see the approximation there. Okay, distributions of sample means with large enough sample sizes could be approximated to normal. Okay, if you have like sample means with large sample sizes and all, could be approximated. Like you can approximate those curves. I'll show you how to approximate that. Yeah, after this slide. So all computable statistics are elegant. I mean, they're perfect. I mean, you'll get good this thing. So normal distribution curve stands for normal here, and this tilde symbol kind of stands for a distribution, and mu is the mean. The sigma square is the variance here. Okay, heavily used in regression analysis. Okay, so regression is something where you have a true value for it. I mean, a true value you'll be having it. Okay, we'll discuss more on regression analysis later. Okay, and good track record means people use it, like it has good scope to identify the patterns and all. Yeah, for that. Example, see, biology, most biological measures are normally distributed, such as height, length of arms, legs, nails, blood. Yeah, height, the height of your arms, length of your arms, like equally divided, normally distributed, right? Yeah, and everything like that. Okay, kind of. And you have IQ tests as well. So IQ tests, it varies from person to person, but it is normally distributed again. And the stock market information as well. So the stock market information is normally distributed, and you can choose the patterns or anything. You identify the patterns present in the data and all, and you do some analysis part later on. Okay, so normal distribution curve looks like this actually. Gaussian distribution is also called as Gaussian distribution, and this is also called as bell curve actually. because it is in the shape of a bell, right? It's in the shape of a bell. See, symmetrical, no skew, symmetrical, no skew. That means if there are no outliers present in the data, I mean, if you have eliminated all the outliers, fine, and you will get this kind of curve actually. The center point is the mean, and from the mean to the curve, the data points, the dispersion of the data points is the sigma. I mean, the standard deviation, you can call that is. Okay, are we clear, guys? Are we clear? Yeah, I guess we are clear. Fine. Okay, so now check this, controlling from the standard deviation. Okay, check the curves here actually. So understand this statement, keeping the standard deviation constant. So if I place the standard deviation as constant, that means the standard deviation is not changing. The standard deviation is same for all the data points. If the mean is varying, then what happens? See, a smaller mean would look like in the same way, but be situated to the left in gray. If you have a smaller mean, the curve will be shifted towards the left. Okay, a larger mean would like in the same way, but be situated towards the right in red. In red, whatever you are saying it now. Yeah, so that will be shifted towards the right actually. Okay, and if you check this, if you there, we have like kept the standard deviation as constant, and we have varied the mean. Like if the mean is small, and or if the standard deviation is same for everything. Here we'll change the standard deviation and we'll place the mean constant. If you do that now, the height increases. That means the data points, the data points which are situated inside the curve, no, it gets compressed actually. Okay, keeping the mean constant, a normal distribution with a smaller standard deviation would be situated in the same spot, but have a higher peak and thinner tails in red. See, in the red, whatever you have, no, it has got thinner tails and thinner tails here, right? A longer standard deviation would be situated in the same spot, but have a lower peak and fatter tails in the gray. If you have longest standard deviation, so if you have the more the standard deviation, the more the spread of data points, right? So that's what we need to assume from these graphs actually. Are we clear? Okay, so there is one more distribution that is called a standard normal distribution. Okay, so the standard normal distribution, what it does is, it is one technique where you can eliminate the outliers. I'm just telling you. Okay, this is just one technique where you can eliminate the outliers. Okay, so let us see, so how does this standard deviation works actually? Okay, so the formula for standard deviation is standard normal distribution. Sorry, no, it's not standard deviation, standard normal distribution. Standard normal distribution is one technique where you can eliminate the outliers. Okay, the formula for standard normal distribution is x minus mu by sigma. That is, x is the value, the data values, mu is the mean, and sigma is the standard deviation. Okay, let us consider okay, we'll remove all this and we'll take these out. Okay, here what I will do is like we'll okay, see, let us see, 78, 56, 7, something like that. So and 84, and then followed by 63, and then 52. These are my values. I've taken 6 random data points of my choice actually. Okay, so okay, first we'll calculate the skew for these data points, right? Actually we have calculated the skew, remember? Okay, it's minus 0.06. That means it is very close to 0. That means the curve is symmetrical. That means that all the points are situated in the same group, and the mean is also situated, and the mean is not affected by any data point here, right? Is that clear? The mean is not affected by any data point here. Yeah, now what I will do is okay, skewness I have done. Okay, observe the skewness properly. Okay, observe the skewness. So that's the skewness there. Okay, I'll just write down skewness. Okay, now what I will do is okay, the formula for standard normal distribution is x minus mu by sigma. So what happens if I use outlier? I'll add an outlier here, like 150. 150 is very small. We'll use 250. Okay, so now skewness, the outlier, right? With skewness with W1 keeping, it's outlier. Okay. Skew. And See, it's 2.44 here. That means the outlier is towards my right. So I understood that my outlier is present towards my right actually. I mean, that means the data points. I mean, to the bottom we have the, or to the bottom side we have the outliers. Now what I will do is I'll use the standard normal distribution formula to eliminate this outlier, and let us check. And let us check what's happening. So how we are eliminating the outlier? Are we affecting the pattern, or are we affecting, I mean, are we doing any loss to the data? The information whatever we have, are we making any loss to the data? Let us see. Okay, the first one is x minus mu. I told you, right? X minus mu by sigma. So we'll calculate each and every data point with the mean. Okay, so first we'll calculate the mean and also the standard deviation. Here I'll use this, take this out. Average. But we got a mean, and check the standard deviation now. STDEV is the formula for standard deviation. Yeah, 71. See, check the value of mean. See, if we consider in this group, no, the mean would be at the center position of this group actually. Since we have an outlier, see, the mean value is increasing. That means mean is easily getting affected by the outliers. For example, if I sample mean, just I'll take the sample without the outlier and then see the output. Average. I do this mean till here. See, it's 63. That means it is present inside that group, and we have good information of mean, and we know the spread of the data points properly now, right? So now see, so in order to eliminate the outliers, we need to make sure the mean comes to 0 and standard deviation to be as 1. Okay, this is one technique. The standard normal distribution, shows us this actually. So we need to make the mean value 0 and standard deviation 1 to eliminate the outliers. So how we are going to eliminate the outliers? Let us see. Okay, I'll use equals to symbol and x minus mu, right? X minus mu. So this is x. I'll use minus followed by this. Yeah, done. And again, next point, x2 minus this. Okay. We have 1, 2, 3, 4, 5, 6, 7, right? No, it's not working. No, it's not working. So I'll delete this. Okay, so we'll just type it quickly. Minus mu. Cool. The third one is completed, equals to x minus mean mu. Again, how many are completed? 4, 1, 2, 3, 4. 63 minus mean. Good. Equals to 52 minus mean. Good. Last one, 250 minus the mean. Good. So now we have done something, like we have x minus mu. We're on the x minus mu here. Okay. Now we'll calculate the average for it again. The mean for it. See, the mean is 0 now. That means you have done something. Like we have, see, the purpose of this is we need to never change the information, and we should never change the pattern and all. Okay, but just we are trying to eliminate the outliers, and there is no loss to the information till now. I'll show you the difference. So how I'm telling that there is no loss to my data. There's no loss to my data. How? Okay, I'll show you. See, so I'll select these and I'll insert a chart. Oh, sorry. I'll insert a chart. Okay, we'll use simple line chart. Finish. So this is one chart which we have information. Okay, for this. Okay, and then yeah, we'll use this. I guess I haven't selected all the data points. I guess let me select. I'll delete it, and then we'll use this. Insert chart. Finish. Okay, now we are good. Yeah. So now I'll take this and I'll insert a chart. See, is the graph same? Yeah, the graph is same, but the values have changed. That means we are bringing it to the smaller dimension. That's it. Remaining everything is same actually. That means we are not changing the information at all. We are not changing its pattern. We are just bringing every data point to small one, like actual to reduce. We need to reduce the mean and also so that all the points gets contracted and comes at one place. It's a small scale actually, small scale. Okay, now we have seen two graphs. I'll just delete these. Okay, now we'll identify the skewness. We'll check the skewness of the entire data, like with the outlier. Okay, still, I mean, see the 2.4, the skewness never changes. That means there is no loss of information actually. The outlier is still there, but what we are doing is we are reducing the scale. That's it. We are reducing the scale. By reducing the scale, what happens is we get the mean value very low. The mean value is 0 now. That means if the scale is reduced, the mean value is 0. That means the outlier, whatever it has, the larger value is coming down to a small scale. Remember, but we are not changing the pattern here. We are just bringing down the outlier to the small scale. Okay, now I'll use standard deviation. We need to check the standard deviation, right? We'll use thing. Still the standard deviation. Oh, okay. Yeah, it's the same. See, the standard deviation is same. Still the spread of data points is there. So now we need to like reduce that spread also as well. So in order to reduce the spread, we use the formula again, x minus mu by sigma. Sigma. Last one is sigma. So I'll calculate the sigma values from here. Okay, equals to x minus mu. This is the value divided by the standard deviation value. This thing. Yeah, I have it. Now again, this divided by standard deviation. We're good. And again, equals to this divided by standard deviation equals this divided by standard deviation equals this divided by standard deviation equals this. Yeah, and so on. We do it for all the values actually. So now check the beauty. After doing this, you see the outlier is reduced to 2 now, which I mean now this 2 is very close to these data points, right? Compared to 250 and all, right? That 2 is very close. Okay, now see the beauty. We'll calculate the skewness again, equal to skew. Okay, I'll use this. See, still the skewness is 2.44 only. That means the value, there is no loss of information. That means there's still an outlier, but see the outlier is very small now. That can be negotiable actually. Okay, now I'll calculate the average. If I calculate the average, my average is 0. Already it's done. Now if I calculate standard deviation, one. That means we have taken out that outlier in a good way. It's a good approach actually. It's a statistical approach where you have eliminated the outlier, that you have changed the scale of the entire outlier actually. Okay. Okay. Now let's check this graph as well. Insert and then we'll do chart line finish. So it's the same thing only. Again, the scale has changed. Now the outlier scale is converted to 2 actually. So 2 is very near to 0, right? Compared to 80 and 250, right? That means we are not changing the pattern. We are just simply changing the axis for the outlier and we are bringing down the mean to the minimum and standard deviation to the minimum so that all the data points will be together, and that's how you can identify the patterns as well. Okay. Yeah. Yeah. Have you guys got any doubt on this topic and the standard normal distribution formula and all? Hello. Hello.